For this, I'm going to focus more on the actual concepts in electric circuits and less on the vert charts themselves. So for example, if we have a circuit in series with a couple of light bulbs, if one of these light bulbs burns out, the whole circuit goes out. So if this bulb burns out, the whole circuit goes dead. Why? Because there's a break in the circuit. However, for a parallel circuit, that would not happen, because even though if one bulb goes out, say it's this one here, there is still a path for the electricity to pass through the second bulb. Also, anytime I add a resistor in series, total resistance will go up. If I add a resistor in parallel, total resistance will actually go down, because I've created an additional path for electricity to travel through. Also, regarding series circuits and parallel circuits, if you have two resistors, but they're not even, a 2 and a 4 ohm resistor, in parallel, the 2 ohm resistor provides less resistance for the circuit, so therefore this one will have more power. In a series, however, it's the opposite effect, because no matter what, the current has to travel through both the 4 and 2 ohm resistor. Therefore, the 4 ohm resistor will have more power. Speaking of power, power is current times voltage. Sometimes you'll be given the resistance. So for example, you're given a resistance of 5 ohms across a voltage of 10 volts, and it would like to know what is the power. Before you can actually solve it by using this equation, you have to use the other circuit's equation, V equals IR. So you'll say 10 equals I times R, which is 5. I in this case will be 2 amps. Now you can take the 10, put it into here, take the 2, put it into here. Power is 2 times 10, or 20 watts. What exactly does a watt mean? If we have 20 watts, that means we burn 20 joules in 1 second. So how many joules will we burn in 5 seconds? 20 times 5 joules, or 100 joules, will be burned in 5 seconds. Although they are called a power company, they don't actually charge you in power, they charge you in energy. Because the energy values are huge, they use a special type of unit called the kilowatt hour. The kilowatt hour is literally a kilowatt, which is 1,000 watts, times an hour, which is 3,600 seconds, or 3.6 million joules. Next important thing is adding resistors. When you add them in series, it's real simple. You can just literally add them. So if I had 2, 4, and 8, the total resistance is 2 plus 4 plus 8, which would be a total of 14 ohms. In parallel, you can't do that. You have to use the inverse style. So 2, 4, and 8. That'll be 1/2 plus 1/4 plus 1/8. And that's 1 over the R total. It is not the actual R total. In order to finish this, I'm going to need a common denominator between 2, 4, and 8. So 4 over 8 plus 2 over 8 plus 1 over 8 will total 7 over 8. But remember, that's 1 over the R total. So we need to do an inverse. 8 over 7 is the true resistance for this circuit. The last thing about calculating resistances in circuits is what if you have a complex circuit. So for example, we have one in series, but then we have these two over here in parallel. So we'll go 2, 4, and 8. This branch needs to be combined before we can add the 2 to everything. But the 2 is in series with everything, so we will add it to the combination of the 4 and the 8. The 4 and the 8 are in parallel, so we'll do 1 over 4 plus 1 over 8. We need a common denominator again. So 2 over 8 plus 1 over 8 is 3 over 8. Remember to flip it. 3 over 8. Bring that over here. 8 thirds will give you a total of 6 thirds plus 8 thirds, or 14 thirds ohms.